Continuing our study of trigonometric functions, we are going to expand beyond acute angles and look at any angle on a graph. And I'm going to put an initial side on my x-axis. This is for standard position. And then I'm going to make this angle down here in the third quadrant. Now, on this graph, I'm going to put a point about right here, and I'm going to label it XY. Now, as you can see here, our X and our Y are in the third quadrant, which means they both have negative signs, which means some of my functions are also going to have negative signs. So as a review from the last section when we studied acute angles, our ratios for our sine, cosine, tangent, cosecant, secant, and cotangent are still all the same. Our sine is still going to be y over r. Now, let's make a note of this. X and y can be positive or negative. R, only positive. And r is the length from the origin to xy. So here's r. Now cosine is x over r, and tangent is y over x. Cosecant is the reciprocal of sine, so that makes that r over y. Secant's the reciprocal of cosine, so r over x, and then cotangent is the reciprocal of tangent. Like that. Now, using these new ratios, or the same ratios actually, we are going to find the trig functions of the angle theta whose terminal side passes through 5, negative 12. Okay, so let's put our angle on here. First of all, let's find 5, negative 12, and 5, negative 12 is going to be about right here. And then we graph our point. So our initial side is here. We have this. Now, this doesn't say whether this is the counterclockwise angle or the clockwise angle. It just matters that it ends, the terminal side passes through 5, negative 12. So it could be either one. So if we go with our ratios, sine is y over r, so y is negative 12, but I don't know what r is. Well, we're still going to use the Pythagorean theorem with x squared plus y squared equals r squared. And when we make our substitutions, like so, that means r squared is 169, which means r is 13. So here's my sine function. My cosine is 5 over 13. This one is positive because we have a positive x. And then my tangent is negative 12 over 5. Now, these are reciprocals, which means you're just going to flip the sine, the cosine, and the tangent and keep the sign. So if it's negative, it stays negative. And just reciprocate those. And there we go. Now we're going to talk about a different type of angle. It's a reference angle. It's the acute angle alpha, which looks like this. And the word ALPHA. Put my L in there, whose measure is determined by the terminal side of theta and the x-axis. So let's put an angle in, and I'll make this a counterclockwise theta. So it's an acute angle, which means it's going to be less than 90 degrees, and it says measure determined by the terminal side of theta. Well, that's this one, and the x-axis, and that's this. So alpha is right here. And it's always going to be positive, and it's always acute. Well, let's look at another one, and I'm going to make a clockwise for a negative angle, and I'm going to make it coterminal with the first one. That means theta comes around here, right there. Now, let's start again with the definition. Measures determined by the terminal side of theta, it's right here, and the x-axis. So look at that. They have the same alpha because they are coterminal, which means they have the same reference angle. Okay, so let's find some reference angles. And sometimes it helps to do a little sketch. So I'm going to do a little sketch here. And my angle is, here's initial side, and 130 is about right there, which means alpha is right there. So our closest x-axis is along this line. That's 180 degrees. So my alpha will be 180 minus 130, which is 50 degrees. So let's look at example 3. I'm going to do another little sketch. And it's a clockwise angle, which is, here's my theta right here, and alpha is right in there. Now there's a couple of ways you can do this. You can see that this is negative 180, and figure out how many degrees it is between negative 180 and negative 210, or you can find the positive coterminal angle, and that's what I'm going to start with doing. So my positive coterminal, negative 210 plus 360 equals 150. Okay, so as we learned on the previous screen, coterminal angles have the same reference angle. And then once you do that, then you can subtract from your nearest x-axis. And this gives us an alpha of 30 degrees. Okay, so example 4. We have a clockwise angle. We're going to go around almost all the way. And we have, it's going to be closest to the 0 side, but 0 is the same as 360 degrees. But if we just find the positive coterminal, let's see what happens, because alpha is right there. So our positive coterminal is negative 330 plus 360, and that's 30 degrees. And this is already an acute angle, so there's alpha. Okay, last one. I'll do a little sketch. This one's a counterclockwise. We'll start here, and it goes about right there. Now my closest x-axis is right here at 180. So alpha, my reference angle is in there. So we'll have 180 minus 100 equals 80 degrees. And this is alpha.